For decades, textbooks and documentaries quoted a familiar number, a number so unbelievably massive that it was almost impossible for the human mind to truly grasp, yet safe enough to print confidently in our science classrooms. 100 to 200 billion galaxies. We trusted this number. It felt precise and authoritative. It felt as though humanity had finally mapped the ultimate boundaries of our cosmic neighborhood and put a definitive border around existence itself. But here is the terrifying truth about human confidence. That number was never a direct count. No astronomer ever looked up into the infinite night and counted 200 billion glowing spirals in the dark. It came from an extrapolation, not a direct observation of the full sky. And if that number was only a statistical guess, a massive mathematical assumption built on an incredibly tiny fraction of the cosmos, then the real question we should have been asking all along is this: how much of the universe are we actually seeing? I used to think the idea of a universe filled with 200 billion galaxies was the most overwhelming concept in modern science. But the reality that was waiting for us in the pitch-black void was fundamentally more terrifying. To understand how we were so spectacularly wrong, we have to go back to the origin of that very first estimate. We have to look at the legacy of the Hubble Space Telescope. In the mid-1990s, astronomers decided to do something that many critics at the time thought was a complete waste of highly valuable resources. They pointed the most advanced and expensive telescope ever built by human hands at a tiny, seemingly completely empty patch of sky near the constellation Ursa Major, a region of space so unimaginably small it was equivalent to looking at the night sky through a tiny drinking straw. For 10 consecutive days, Hubble stared unblinking into the absolute cold dark. When the final image data downloaded to Earth, the results sent shockwaves through the scientific community. That patch of sky was not empty. That single long exposure photograph revealed roughly 3,000 individual galaxies, shimmering smudges of ancient starlight scattered across an endless void. This became known as the Hubble Deep Field. The mathematical logic that followed this monumental discovery was wonderfully simple. Count the galaxies trapped in this one microscopic region of space, and then scale that number up to cover the entire three-dimensional sphere of the night sky. The conclusion they reached was historically monumental, an estimated total of 100 to 200 billion galaxies drifting through the cosmos. But there was a fatal flaw buried deep within this brilliant logic. This was entirely a statistical extrapolation generated from a very microscopic visual sample. It was the scientific equivalent of scooping a single cup of water from the middle of the ocean, counting the tiny fish swimming inside that cup, and then trying to accurately guess the total biological population of the entire Pacific Ocean. I always assumed that what Hubble saw in that deep field image was the absolute edge of creation, the final frontier of light. But the truth is, we were completely blind to what was really lurking out there. There was a harsh physical limitation to what the Hubble Space Telescope could actually perceive. We proudly thought we were looking all the way back to the dawn of time, but in reality we were just staring through an incredibly dusty keyhole. You see, Hubble was designed to primarily observe visible and near-ultraviolet light. It sees the mechanical universe in the exact same spectrum that our fragile human eyes do, just magnified to an extraordinary degree. But our universe is not static. It is aggressively expanding in all directions, and as the fabric of space stretches out, it physically pulls the light from those ancient distant galaxies along with it. This bizarre phenomenon is known as cosmological redshift. The farther away a galaxy is located from Earth, the faster it is moving away from us, and the more its light waves are stretched out over the vast distances. Those short, energetic, visible wavelengths are stretched so violently that they shift entirely out of the visible spectrum and plunge deep into the infrared. And Hubble, for all its magnificent power, is mostly blind to deep infrared light. The implication of this physics lesson was profound and deeply unsettling for astronomers. Countless distant galaxies emit light that Hubble simply cannot detect, no matter how long it stares into the dark. The universe may contain vastly more stellar empires not because they magically appeared later in the timeline of reality, but because they have been silently hiding in the invisible spectrum all along, waiting for us to open our eyes. For years, the scientific community sat comfortably with the 200 billion number until the year 2016, when a dedicated team of researchers led by astrophysicist Christopher Consolis decided to attack this missing data problem from a completely different angle. They realized that if our current generation of telescopes could not physically see these ancient red-shifted galaxies due to the limits of visible light, perhaps our mathematics could predict their existence. The team embarked on an exhaustive archaeological dig through the cosmos using deep space surveys and incredibly complex computer models of galaxy evolution. They painstakingly simulated how cosmic structures formed over billions of years, mathematically calculating how many incredibly faint and physically unresolved galaxies must logically be hiding in the dark background just to make the current visible universe mathematically and structurally possible. They were looking for the missing mass of creation. When the supercomputers finally processed the data and spit out the ultimate result, the number was so astronomically massive it completely shattered the previous scientific consensus. They estimated that up to 2 trillion individual galaxies were packed tightly into the fabric of the observable universe. 2 trillion. 10 times more than anyone had ever confidently predicted. But it is absolutely critical to understand the nature of this revelation. This was still fundamentally a mathematical ghost hunt. This staggering 2 trillion figure was a brilliant model-based estimate, but it was emphatically not a direct observational count. The scientists had the math, they had the theoretical physics, but they did not have the definitive visual proof. To prove that 2 trillion galaxies were actually out there drifting in the freezing dark, humanity needed a new kind of eye. They needed a machine capable of seeing the invisible. Enter the James Webb Space Telescope. This was not just an upgrade to Hubble. This was the most complex, incredibly ambitious engineering marvel ever built by our species, designed with one specific and ruthless purpose: to hunt down the invisible universe. Unlike Hubble, which relied on visible light, Webb was constructed with immense golden beryllium mirrors specifically tuned and hyper-sensitized to capture deep infrared radiation. It was mathematically designed to pierce straight through the thick, suffocating clouds of cosmic dust and capture the ancient, stretched-out photons arriving from the very dawn of creation. When Webb finally reached its orbit 1 million miles away from Earth, unfolded its massive sunshield and opened its golden eye to the cosmos, it stared into the exact same seemingly empty patches of sky that Hubble had looked at decades earlier. The results were instantly breathtaking and profoundly paradigm-shifting. Webb immediately began detecting thousands upon thousands of massive, intensely glowing galaxies that were completely fundamentally invisible to Hubble. It was successfully looking deeper into the early universe than humanity had ever dared to dream. Webb's initial deep-field observations strongly supported the mathematical models of 2016, confirming that countless galaxies had indeed been hiding in the cosmic dark. The universe was unequivocally vastly more crowded than our textbooks claimed, but while Webb proved that these hidden galaxies existed, it still could not give us a final definitive total count of 2 trillion. Instead of just giving us a neat number, Webb handed us something much more terrifying. A profound mystery that threatens to break modern physics itself. Because when Webb looked back to the absolute earliest epochs of cosmic time, staring into the abyss just a few 100 million years after the Big Bang, it saw things that simply should not be there. According to our fiercely protected standard model of cosmology, known in physics as the lambda cold dark matter model, the early universe should have been a chaotic, violent soup of hydrogen and helium gas, very slowly clumping together over billions of years to form small, ragged, primitive baby galaxies. But Webb did not find babies in the dark. It found absolute cosmic monsters, It observed entire galaxies at the dawn of time that appeared to be vastly more massive, incredibly structured, and significantly more dynamically evolved than the standard model mathematically allowed. It was the scientific equivalent of digging into an ancient terrestrial archaeological site, expecting to find primitive stone tools, and instead uncovering a fully functioning modern metropolis. The tension pulsating through the global scientific community right now is absolutely palpable. These groundbreaking observations simply do not fully align with our current predictions of how the universe was built. The fundamental timeline of creation seems to be broken. Now, to be clear, this is not a complete and total breakdown of all known physics just yet. No one is throwing away the textbooks tomorrow, but it is currently the most intense, aggressive, and highly debated active area of investigation in modern astronomy. And the possible explanations for what we are seeing are even wilder than the mystery itself. The scientific community is currently scrambling to explain exactly what the James Webb Space Telescope is showing us in the deepest reaches of the infrared universe. When you find monumental structures that seem to violate the established timeline of cosmic evolution, you cannot just throw away a century of astrophysics overnight. Instead, astronomers are carefully formulating radical new hypotheses to explain this impossible anomaly. The first major theory involves a drastic rethinking of star formation efficiency in the primordial cosmos. In our modern local universe, galaxy building is a relatively slow and inefficient process. But some physicists are now suggesting that in the extremely dense ultra-hot conditions right after the Big Bang, the physical rules of ignition might have been fundamentally different. Perhaps those ancient primordial gas clouds collapsed and ignited into massive stars at a hyper-accelerated rate, burning through their fuel with an unprecedented and ferocious efficiency that we simply do not see today. If true, this would mean those early galaxies grew unnaturally fast, producing enough starlight to be detected by Webb much earlier than our standard models predicted. But there is a second, even more exotic explanation currently being fiercely debated across university campuses worldwide. It involves the invisible scaffolding of the universe itself, which we call dark matter. We know that dark matter provides the essential gravitational glue that pulls ordinary gas together to form galaxies. Our highly protected standard model assumes that dark matter behaves in a relatively predictable, cold and slow manner. But what if dark matter behaved entirely differently in the extreme youth of the universe? Some theoretical physicists propose that early dark matter might have possessed bizarre properties that allowed it to clump together much faster, creating massive gravitational wells that rapidly, violently sucked in surrounding gas to build these giant galaxies in record time. If this hypothesis is correct, then Webb is not just taking pictures of early stars, it's actively mapping the mysterious and entirely unknown evolutionary history of dark matter itself. Finally, we must acknowledge the most humbling scientific possibility of all. We might simply be misinterpreting the physical data. The faint red light arriving from these ancient galaxies has travelled for over 13 billion years, passing through vast, endless oceans of expanding space, twisting through massive gravitational lenses, and fighting through thick walls of cosmic dust. It is entirely possible that severe measurement uncertainties or extreme observational distortions are making these distant cosmic structures appear much larger and significantly more massive than they actually are in reality. This is the brutal but beautiful nature of the scientific method. These potential explanations, from hyperactive star formation to exotic dark matter physics, are currently just hypotheses. They are emphatically not definitive conclusions. We are standing at the absolute bleeding edge of human knowledge, staring into a dark frontier where our absolute best theories are being pushed to their absolute breaking point. The tension in the astronomical community is not about proving who was right in the past. It is about surviving the overwhelming influx of raw, impossible data that is currently flooding down to Earth. Every single week, new theoretical papers are published attempting to solve the mystery of these impossible anomalies. What remains undeniably clear is that the discovery of these massive early structures has shattered the comfortable illusion we held about our origins. We have the data, but we are still desperately searching for the truth. To truly appreciate the chaos currently unfolding in modern astrophysics, we must understand exactly why simply counting galaxies is such a monumentally difficult and frustrating task. You might logically assume that scanning the night sky is just a matter of pointing a powerful enough lens and taking a careful tally, but the universe actively and aggressively fights against our attempts to map its boundaries. The first major astronomical hurdle is the sheer overwhelming abundance of extremely faint dwarf galaxies. Our own local cosmic neighbourhood is heavily littered with these tiny dim collections of ancient stars. They are incredibly difficult to spot even when they are relatively close to Earth. Now try to imagine the sheer physical impossibility of detecting those incredibly faint ghostly objects when they are scattered billions of light years away across the aggressively expanding void. They become completely invisible instantly, drowning in the vast, suffocating cosmic dark. The second immense physical challenge is the extreme high redshift of the most ancient and distant structures. As we established earlier, the universe is expanding at a rapidly accelerating rate, physically stretching the fragile light of early galaxies so far into the deep infrared spectrum that only highly specialized and extremely expensive instruments, like the James Webb Space Telescope, can even register their thermal existence. And this brings us to the ultimate physical limitation, the absolute technical sensitivity limits of our human-engineered instruments. A telescope is effectively a massive mechanical bucket designed to catch microscopic raindrops of ancient starlight. If a galaxy is incredibly far away, its dying light might only deliver a few scattered photons to our golden mirrors every single hour. If our technological bucket is not big enough or sensitive enough to catch those solitary photons, those massive galaxies remain entirely undetected, existing only as mathematical ghosts. This frustrating reality leads to a profound and unavoidable scientific insight. Every single time humanity manages to build a newer, bigger, and vastly more sensitive telescope, we inevitably reveal massive, sprawling populations of cosmic objects that were previously totally invisible to us. The universe does not suddenly magically create more galaxies every time we look up. We just finally manage to open our eyes wide enough to see what has been silently drifting in the dark the entire time. To truly internalize the sheer terrifying scale of a universe containing 2 trillion galaxies, we must temporarily abandon our standard human metrics of distance and size. The human brain is simply not evolved to process numbers of this magnitude. We struggle to comprehend the true physical scale of our own planet, let alone the massive, terrifying emptiness of the solar system. So let us break down this cosmic mathematics into a perspective that forces us to confront our absolute insignificance in the dark. Our home, the Milky Way, is considered an entirely average, largely unremarkable spiral galaxy, drifting through a minor galactic group. Yet it contains roughly 100 to 400 billion individual stars. Each one of those stars is a massive roaring nuclear furnace, many of them absolutely dwarfing our own sun in both sheer physical size and furious energy output. Now take that staggering number of stars furiously burning in our single average galaxy and multiply it by the 2 trillion individual galaxies that Christopher Consulis and his team predict currently occupy the observable universe. The resulting mathematical figure is a number so unimaginably vast that it renders human language completely useless. We are talking about hundreds of sextillions of stars. That is a one followed by 23 zeros. There are significantly more violently burning stars scattered across the freezing void of the observable universe than there are individual grains of sand on every single beach, desert, and ocean floor on Earth combined. But the overwhelming mathematics of creation do not stop with just stars. Over the past 2 decades, the Kepler Space Telescope and subsequent massive exoplanet surveys have violently revolutionized our understanding of stellar systems. We now possess the statistical certainty that planets are not rare astronomical anomalies. They are the standard cosmic rule. Current astrophysical data strongly suggests that on average almost every single star you can mathematically account for hosts at least one orbiting planetary body. Many of these systems boast incredibly complex orbital architectures with multiple rocky and gaseous worlds, much like our own solar system. When we extrapolate this hard observational data across the 2 trillion galaxies, we're forced to visualize a universe practically overflowing with planetary bodies. Trillions upon trillions of rocky worlds, massive radioactive gas giants, rogue planets wandering blindly in the dark interstellar space, and silent ocean worlds locked permanently in ice. Yet in the face of this overwhelming abundance of cosmic real estate, we must remain rigorously anchored to cold scientific reality. While the sheer mathematical probability seems to scream into the void that we cannot possibly be alone in this sprawling infinite dark astrophysics, is a strict discipline of observation, not romantic speculation. The staggering number of galaxies, stars, and potential planets does not automatically guarantee the existence of extraterrestrial biology or advanced civilizations. What it does absolutely guarantee, however, is that the cosmic arena is vast beyond human comprehension, and the fundamental chemical building blocks of existence are scattered violently across every corner of the sky. Furthermore, we must remember the most humbling physical limitation of all. This mind-bending figure of 2 trillion galaxies is strictly confined to what we call the observable universe. The observable universe is not the entire universe. It is merely a temporary spherical bubble of light surrounding Earth, strictly limited by the absolute speed of light and the 13.8 billion years that have passed since the Big Bang. It is an absolute physical certainty mathematically proven by cosmic inflation that the actual universe extends infinitely far beyond this visual horizon. The 2 trillion number, as terrifyingly large as it is almost certainly a massive underestimation. It is merely the absolute lower bound, a temporary numerical placeholder, a fleeting illusion of boundary until our technological eyes can pierce even deeper into the endless expanding dark. When we take a step back from the raw, overwhelming data pouring out of the James Webb Space Telescope and analyze the broader historical context of astronomy, a deeply humbling and undeniably terrifying pattern begins to emerge. Every single time human beings have boldly claimed to have finally measured the true absolute extent of the cosmos, the universe has profoundly humiliated us. To truly understand the psychological weight of this 2 trillion figure, we must travel back just a single century to the early 1920s. It is almost impossible to believe today, but at that specific moment in human history, the absolute consensus among the greatest scientific minds on Earth was that our Milky Way galaxy was the entire universe. Period. Everything that existed, every star, every glowing nebula, every rocky world was thought to be firmly contained within our one single, lonely island of light floating in an endless empty dark. The sheer idea of other galaxies existing outside our own was considered radical fringe science. We thought we were the center of a very small, very manageable reality. Then, an astronomer named Edwin Hubble, using the massive Hooker telescope at the Mount Wilson Observatory, identified a specific type of pulsating star called a Cepheid variable, inside what was then known simply as the Andromeda Nebula. That single solitary observation violently shattered the universe of the 1920s. Mathematics proved that Andromeda was not merely a local cloud of gas drifting inside our galaxy. It was an entirely separate, massive, independent stellar empire located an unimaginable 2.5 million light-years away. Overnight, the universe expanded from one isolated island to an unfathomably vast ocean containing multiple island universes. As the 20th century progressed and our terrestrial optical telescopes grew larger and significantly more sophisticated, that number continued to multiply with terrifying speed. We went from knowing of just a few neighbouring galaxies to cataloguing hundreds, then meticulously mapping thousands, and eventually realising there were millions. Then, as we discussed earlier, humanity placed the Hubble Space Telescope above the distorting atmosphere of our planet, and suddenly the number violently exploded into the hundreds of billions. And now today, with the hypersensitive golden infrared eyes of the James Webb Space Telescope, we have aggressively crossed the terrifying threshold into the trillions. Do you see the undeniable mathematical pattern forming here? The fundamental physical structure of the cosmos is not changing. The universe is not magically generating billions of new massive galaxies every few decades, just to confuse human scientists. The cosmos is completely silent and utterly indifferent to our existence. It is only our fragile human ability to observe the dark that is slowly, painfully improving. Every single time we upgrade our technological eyes, we are forced to realize that the dark was never actually empty. It was always densely populated by ancient cosmic structures that our previous generation of machines were simply too weak, too small, or too blind to perceive. What we arrogantly call the known universe is never an actual physical boundary of reality. It is merely a temporary reflection of the current absolute limits of human engineering. We keep drawing maps of the edge of the world, and the universe keeps forcing us to erase them. The 2 trillion number is just the latest psychological comfort blanket we have wrapped around ourselves to make the infinite feel measurable. We are continuously violently revising the size of infinity, and there is absolutely no reason to believe that this pattern will ever stop. So here we stand at the very edge of human comprehension. We've stared into the deepest, darkest corners of the cosmos and realized that the majestic 200 billion galaxies we once confidently taught in our schools was nothing more than a profound illusion. We were merely looking through a dusty keyhole. Now the James Webb Space Telescope has kicked the door completely open, revealing a staggering 2 trillion galactic empires hiding in the infrared dark. But the most terrifying and beautiful realization is not the number itself. It is what that mathematical revelation represents. If our absolute best, most advanced technology can still only see a tiny fragmented fraction of the observable universe, if every single time we open our technological eyes a little wider, we find trillions of new massive structures defying our standard models, then what else is patiently waiting for us out there in the dark? How much of reality remains completely invisible, permanently hidden just beyond our current mathematical and technological limits? We are already designing and building the next generation of super telescopes, massive machines that will eventually make James Webb look like a primitive toy. And when those massive new eyes finally open and look into the absolute freezing dark, the numbers will inevitably change again. The universe is not finished humiliating us. The true unfathomable scale of existence is still out there waiting to be found. When the first deep infrared datasets from the James Webb Space Telescope began arriving on Earth, the astronomical community was not preparing for a sudden collapse of established theory. They were simply expecting a high-resolution confirmation of a long-held timeline. The primary target was a specific and crucial epoch in cosmic history, located roughly 500 million years after the initial expansion event. In the standard models of modern astrophysics, this specific era is formally known as the Cosmic Dawn. For decades, our theoretical calculations painted a very specific picture of this time period. We envisioned it as a profoundly quiet phase of existence, a vast pristine expanse of cooling primordial hydrogen and helium gas, where the very first primitive stars were only just beginning to slowly ignite. It was supposed to be a slow and highly inefficient gradual awakening of matter. The fundamental assumption shared by researchers across the globe was that if we looked back far enough into the deep infrared spectrum, we would find an infant universe, a simple, unstructured environment entirely devoid of any massive, complex gravitational bodies. The telescopes were tuned to find the delicate, fragile beginnings of stellar formation. But the raw data that materialized on the analysis screens at the Space Telescope Science Institute told a completely different and fundamentally contradictory story. The early universe was not a quiet, slow-developing nursery. Scattered across that primordial background, Webb detected the unmistakable, highly energetic electromagnetic signatures of incredibly dense singularities, black holes. But these were not the small stellar mass remnants of the very first dying stars. The preliminary mass calculations derived from the accretion disk luminosities returned figures that immediately defied the standard models of stellar evolution. These objects possessed the mass of billions of suns. They were fully mature structures operating at a scale that our current physical laws dictate should require several billions of years of gradual continuous material accumulation to achieve. Yet there they were sitting precisely in a timeline where they mathematically had absolutely no right to exist. I used to think that the most profound discoveries in observational astronomy would simply involve finding new elemental compositions or mapping distant exoplanets. But the stark reality of this new deep field data is far more intellectually demanding. We pointed our most advanced technological instrument at the very dawn of time, expecting to find the gentle, fragile beginnings of cosmic structure, and instead we found massive mechanisms that were already fully functioning. The established timeline of the early universe is broken, and we are forced to confront the limits of our own theoretical frameworks. To truly comprehend the nature of these anomalies, we must first understand exactly how the James Webb Space Telescope gathers its intelligence. It does not take simple photographs in the way our terrestrial cameras do. It is essentially a massive, incredibly precise spectrometer, designed to dissect infrared radiation into its fundamental components. When astrophysicists directed Webb toward these specific coordinates in the early universe, they were searching for the collective thermal glow of primordial hydrogen, slowly igniting into the first generations of stars. Instead, the spectroscopic data returned concentrated point sources of light that were unimaginably intense. The sheer luminosity of these objects was completely disproportionate to any known stellar cluster. These isolated points of light were radiating with an energy output that eclipsed the combined brilliance of an entire mature galaxy. In the field of astrophysics, this specific signature is recognized as a quasar. However, a quasar is not a solid physical object. It is a highly active process. It is the blindingly bright accretion disk of superheated gas and dust violently swirling around a supermassive singularity before passing beyond the event horizon. The light we are detecting is the intense frictional energy of matter, as it is relentlessly compressed and heated to millions of degrees by an overwhelming gravitational force. The paradox here is one of scale and visibility. In our modern local universe, we observe quasars housed within massive, well-defined galaxies. The surrounding galaxy provides the necessary fuel to sustain the accretion process. But in these ancient observations from the cosmic dawn, the light from the accretion disk is so profoundly dominant that it completely washes out any sign of a host galaxy surrounding it. We are observing engines of staggering power seemingly operating in the void without the immense galactic infrastructure that physics dictates should be required to feed them. The sheer volume of material necessary to generate this level of sustained luminosity points to a central mass that completely defies the expected timeline of cosmic evolution. The telescope has essentially captured the intense thermal signatures of immense gravitational engines, operating in a time period where the necessary building blocks for their existence should not yet be fully formed. How do we actually weigh an entity that is entirely invisible and located near the absolute edge of the observable universe? The process is a masterpiece of deductive physics relying entirely on the extreme gravitational influence the singularity exerts on the chaotic material trapped within its immediate vicinity. When astrophysicists meticulously process the spectroscopic infrared data captured by the James Webb Space Telescope, they are strictly analyzing the behavior of the hyperactive gas violently swirling within the accretion disk. As this primordial material spirals inward towards the inescapable boundary of the event horizon, it accelerates to terrifying fractions of the speed of light. Because this superheated disk of gas is rotating rapidly relative to our specific line of sight on Earth, the light emitted from the side of the disk moving towards our telescope is physically compressed, shifting towards the higher energy blue end of the spectrum. Conversely, the light originating from the side of the disk rapidly receding from us is stretched, shifting towards the lower energy red end of the spectrum. In observational astrophysics, this physical phenomenon is known as Doppler broadening. By precisely measuring the extreme widths of these specific elemental emission lines within the spectrum, researchers can mathematically extract the exact rotational velocity of the accretion disk. Once the terrifying velocity of this swirling gas is definitively established, the researchers apply the fundamental principles of orbital mechanics, specifically relying on the virial theorem to calculate the exact amount of central mass required to keep that hyper-accelerated material tethered in its orbit. It is a cold, strictly mathematical deduction. The faster the surrounding gas is moving, the more massive the central singularity must logically be to prevent the entire accretion disk from violently tearing itself apart and scattering into the interstellar void. When the supercomputers finally finished crunching the Doppler profiles of these specific early universe targets, the scientific community was met with calculations that simply broke their established evolutionary models. The data definitively proved that these central objects were not merely large by early universe standards. They were absolute behemoths containing the unimaginable mass of 1 billion to 10 billion times that of our own Sun. A singularity of this immense scale exerts a gravitational dominance so absolute that it dictates the structural evolution of an entire galactic neighborhood. To truly contextualize the absurdity of this measurement, we must look at the supermassive black hole located at the very center of our current Milky Way galaxy, Sagittarius A star. Our local singularity possesses a mass of roughly 4 million suns, and it took our galaxy almost the entire 14 billion year history of the universe to slowly feed it to that relatively modest size. Yet the advanced instruments aboard the Webb telescope are definitively measuring black holes hundreds to thousands of times more massive, fully operational, at a time when the universe itself had barely begun its cosmic expansion. I used to assume that time in the early universe moved with the same predictable rhythm we experience today, but the chronological mathematics surrounding these massive singularities are actively breaking our understanding of temporal mechanics. To truly grasp the severity of this scientific crisis, we must look at the strict chronological boundaries established by the cosmic microwave background. Precision measurements from the Planck satellite have definitively anchored the origin point of the universe, the Big Bang, at exactly 13.8 billion years ago. The specific infrared light currently flooding into the sensors of the James Webb Space Telescope from these hyperactive quasars has travelled for over 13.3 billion years to reach Earth. This places the physical existence of these fully mature billion solar mass black holes at roughly 400 to 500 million years after the initial cosmic expansion. In the grand thermodynamic timeline of astrophysics, 500 million years is barely a momentary flash. It is the absolute infancy of existence, where the universe was only just emerging from the cosmic dark ages. Now we must introduce the rigid mathematical constraints of black hole evolution. According to standard physical models, black holes do not spontaneously generate with the mass of a billion suns. They must begin as relatively small gravitational seeds typically born from the collapsing core of a massive primordial star. These first-generation stars, known as population 3 stars, were completely devoid of heavy metals and could grow quite massive, but their subsequent core collapse would still only leave behind a singularity remnant of perhaps 100 to a few hundred solar masses. For that incredibly tiny seed to eventually grow into a supermassive entity, it must continuously violently pull in and consume surrounding neutral hydrogen gas. But there is a fundamental thermodynamic restriction built into the fabric of space itself. When matter falls toward an event horizon, it heats up to millions of degrees and emits intense outward radiation. If the gas falls in too quickly, the outward pressure of this radiation becomes so overwhelming that it physically repels the remaining gas away, entirely halting the accretion process. This maximum theoretical feeding rate is governed by a strict mathematical boundary known as the Eddington limit. When astrophysicists apply this absolute maximum continuous growth rate to a standard stellar mass seed, they calculate a specific duration required for the black hole to double its mass, known as the Salpeter timescale. To mathematically evolve from a 100 solar mass seed to a staggering 1 billion solar mass supermassive engine requires roughly 16 complete mass doubling cycles. Even if this primordial singularity fed continuously at the absolute maximum physical speed limit, without a single second of interruption, the thermodynamic mathematics rigidly dictate that the entire accretion process requires an absolute minimum of 800 million to 1 full billion years of uninterrupted optimal growth. And therein lies the catastrophic temporal paradox that is currently paralyzing the astronomical community. The universe at the exact moment we're observing these fully mature structures is at most 500 million years old. The required physical assembly time for these massive gravitational engines geometrically exceeds the entire physical age of the cosmos itself by hundreds of millions of years. We are not just looking at celestial objects that are slightly too massive for their environment. We are staring directly at mathematically impossible cosmic anomalies that appear fundamentally older than the very fabric of space and time they reside within. The foundational chronological models of the early universe have been completely shattered by this single inescapable calculation. To properly understand why the astronomical community is currently in a state of theoretical panic, we have to strip away the complex mathematics and return to the fundamental mechanics of stellar evolution. We must examine the absolute baseline for how a singularity is traditionally forged in the modern universe. For decades, astrophysics has relied on a very elegant and incredibly violent mechanism known as core collapse. In the standard model, black holes are not born, they are the final terminal remnants of a massive dying star. Let us visualize the life cycle of what astronomers call a population 3 star. These were the very first luminous bodies to ignite in the primordial universe, composed almost entirely of raw hydrogen and helium gas. Because they lacked the heavier elements that regulate stellar temperatures today, these early stars could grow to immense proportions, sometimes reaching hundreds of times the mass of our own Sun. For a few brief million years, these massive spheres of incandescent plasma exist in a delicate state of hydrostatic equilibrium. The immense inward crushing force of their own gravity is perfectly balanced by the explosive outward pressure generated by the continuous nuclear fusion of hydrogen into heavier elements within their core. But this balance is strictly temporary. Eventually, the core fuses lighter elements all the way up the periodic table until it creates solid iron. Iron fusion does not release energy, it actively absorbs it. In a fraction of a second, the outward thermal pressure completely fails. The entire staggering mass of the star abruptly collapses inward, driven by an inescapable gravitational freefall. The outer layers slam into the dense iron core at a significant percentage of the speed of light, triggering a catastrophic rebound explosion known as a supernova. But at the very center, the inward gravitational pressure is so absolute that it crushes the remaining protons and electrons into a single dimensionless point of infinite density. A singularity is created. This is the standard, rigorously tested origin story for a black hole. But here is the critical mathematical flaw that shatters our understanding of the early universe. Even when the most massive population 3 stars undergo this catastrophic core collapse, they shed an enormous amount of their mass during the supernova phase. The resulting singularity that is left behind in the dark is relatively microscopic in the grand scale of astrophysics. It is what we classify as a stellar mass black hole, typically weighing anywhere from 10 to perhaps 100 times the mass of our Sun. This is the fundamental seed. It is a tiny isolated gravitational well. Now we must return to the terrifying data transmitted by the James Webb Space Telescope. We are observing mature singularities possessing the mass of billions of suns operating just a few 100 million years after the initial expansion of space. If we assume that these massive entities started as standard stellar mass seeds, the mathematical leap required is simply insurmountable. How does an object weighing 100 solar masses aggressively multiply its own density by a factor of 10 million in a time frame that is physically shorter than the evolutionary lifespan of a standard galaxy? The traditional mechanism of stellar death is fundamentally insufficient to explain the existence of these structures. They are simply too massive, and the available time is simply too short. To understand why a singularity cannot simply consume matter at an infinite rate, to achieve these massive sizes, we must examine a fundamental physical boundary known as the Eddington limit. Sir Arthur Eddington, a brilliant astrophysicist of the early 20th century, derived a mathematical equilibrium that governs the behavior of all luminous accreting bodies in the universe. It is a strict continuous balancing act between two violently opposing forces. On one side, you have the overwhelming inward pull of gravity generated by the central mass relentlessly dragging surrounding primordial hydrogen and helium gas toward its event horizon. On the other side, you have the intense outward pressure of electromagnetic radiation. As the infalling gas compresses and accelerates to fractions of the speed of light, it superheats through extreme kinetic friction. This superheated plasma releases immense amounts of high-energy photons primarily in the ultraviolet and X-ray spectrums. Light possesses physical momentum. When a massive concentrated flood of outward-bound photons continuously collides with the inward-falling gas particles, it physically pushes back against the accretion flow. The Eddington limit represents the exact mathematical point where the outward radiation pressure perfectly equals the inward gravitational pull. If the central singularity attempts to pull in matter faster than this strict limit, the resulting surge in radiation pressure becomes so intense that it literally blows the surrounding fuel source away into interstellar space, immediately starving the core and halting the growth process. It is a self-regulating thermodynamic mechanism built into the fundamental laws of physics. An accreting body is forced by nature to feed at a strictly regulated maximum velocity. This limit is a rigid physical barrier. When we apply this mathematical absolute to the infrared spectroscopic data retrieved by the James Webb Space Telescope, the temporal paradox deepens significantly. The velocity and luminosity profiles of the accretion disks surrounding these ancient singularities indicate that they are currently consuming matter at rates that technically violate the standard Eddington boundary. They are pulling in gas with such aggressive force that the resulting radiation should logically tear the entire surrounding structure apart, yet they remain entirely stable and continue to grow. Some theoretical models suggest that if the infalling gas is highly structured, perhaps funneling down through narrow dense polar columns, rather than a uniform spherical cloud, the outward radiation might escape sideways through the thinner equatorial regions, allowing the singularity to effectively cheat the Eddington limit. This highly specialized mechanism is known as super-Eddington accretion. However, even when supercomputers rigorously simulate these highly optimized exotic feeding scenarios, the temporal efficiency gains are strictly marginal. They might allow a singularity to double its mass slightly faster than the standard Salpeter timescale predicts, but they absolutely do not provide the exponential mathematical leap required to bridge the massive gap between a stellar remnant seed and a billion solar mass entity within a mere 500 million years. The chronological deficit remains completely insurmountable. The known physics of accretion simply cannot build these massive structures from scratch in the narrow window of time available. When confronted with the strict thermodynamic boundaries of the Eddington limit, Theoretical astrophysicists do not simply concede defeat to the void. If a standard uniform spherical accretion model fundamentally prevents the rapid formation of these massive singularities, the scientific community is forced to hunt for localized mathematical loopholes within the laws of physics. This desperate search for an evolutionary shortcut leads directly to the highly complex and heavily debated framework known as super-Eddington accretion. To successfully bypass the immense outward crushing force of radiation pressure, we must completely abandon the concept of a smooth uniform cloud of infalling gas. Instead, we must introduce the chaotic and violently unpredictable influence of extreme magnetic fields. As the primordial hydrogen gas spirals inward at significant fractions of the speed of light, it generates immense magnetic turbulence. In highly specific and mathematically fragile theoretical scenarios, these immense magnetic fields can physically restructure the entire architecture of the accretion disk. The fields force the infalling material into incredibly dense hyperaccelerated columns located strictly along the equatorial plane. Simultaneously, the intense outward radiation pressure, the very force that normally chokes the black hole, is violently funneled away through the paths of least physical resistance, escaping in blindingly bright jets along the polar axes. This highly specialized geometric configuration creates a thermodynamic exhaust system. It theoretically allows the singularity to continue continuously dragging in heavy matter from its equator, while safely venting the prohibitive photon radiation from its poles. In the field of astrophysics, this is known as the photon trapping mechanism. It is an elegant physical workaround, essentially allowing the central mass to consume surrounding gas significantly faster than the standard physical speed limit allows. However, when astrophysicists feed this exotic theoretical framework into their supercomputers and apply it directly to the hard infrared spectroscopic data retrieved by the James Webb Space Telescope, the chronological mathematics still fundamentally fail to resolve the crisis. Super-Eddington accretion is not an infinite magic solution. It is a highly unstable and violently erratic thermodynamic state. The immense polar radiation funnels are fundamentally volatile, frequently collapsing under their own kinetic energy and physically choking off the very equatorial accretion columns they are mathematically supposed to protect. The process operates in violent intermittent bursts rather than a smooth continuous flow. Furthermore, even if we deliberately bias our mathematical models and assume a perfectly stable, uninterrupted state of continuous super-Eddington accretion, from the very moment of stellar collapse, the temporal efficiency gains are merely incremental. This specialized geometric feeding mechanism might successfully accelerate the mass doubling process by a factor of 2 or perhaps 3, but it absolutely cannot provide the staggering exponential multiplication required to bridge the massive physical gap between a tiny stellar mass seed and a mature billion solar mass entity in a window of less than 500 million years. The fundamental mathematical deficit remains glaring and absolute. Even with the most extreme physical loopholes applied, the primordial universe simply did not provide enough physical time for these magnetic mechanisms to construct the massive gravitational engines we are currently observing in the deep field data. When the mathematical limitations of both standard stellar core collapse and extreme magnetic accretion become insurmountable, theoretical physicists are forced to explore entirely different mechanisms of creation. If the universe does not provide enough time to grow a massive singularity from a tiny seed, then the logical alternative is to bypass the stellar growth phase entirely and synthesize a massive seed right from the beginning. This specific theoretical framework is formally known within the astrophysical community as the direct collapse hypothesis. The fundamental premise of this model is staggeringly violent. It proposes that in the highly dense environments of the early universe, massive primordial clouds of pure hydrogen gas containing up to 100,000 times the mass of our Sun did not fragment to form individual stars. Instead, under highly specific and extreme gravitational conditions, the entire monolithic gas cloud rapidly destabilized and collapsed uniformly inward, directly crushing itself into a massive singularity without ever igniting nuclear fusion. If this direct collapse mechanism is physically viable, it would instantly provide the massive gravitational seeds required to solve the chronological paradox. A singularity born with a mass of 100,000 suns could theoretically accrete enough surrounding material within 500 million years to match the observational data currently returning from the James Webb Space Telescope. However, the thermodynamic reality of the primordial universe severely restricts this elegant theoretical shortcut. For a massive gas cloud to successfully collapse under its own gravity, it must be able to efficiently radiate away its internal thermal energy. If the cloud remains too hot, the internal outward thermal pressure will successfully resist the inward gravitational pull, forcing the cloud to fragment into thousands of smaller pieces, which then independently ignite to form a standard cluster of normal stars. In the early universe, the primary chemical mechanism for cooling these massive gas clouds was the formation of molecular hydrogen. Therefore, to achieve a direct uniform collapse, the formation of molecular hydrogen within the cloud must be completely suppressed. This requires a highly specific external environmental trigger. The collapsing gas cloud must be continuously bombarded by a very precise spectrum of ultraviolet radiation, specifically Lyman-Werner photons emitted by a violently active neighboring galaxy. This intense radiation physically destroys the molecular hydrogen within the target cloud, preventing it from cooling and fragmenting while simultaneously allowing the entire massive structure to slowly contract until it reaches the critical threshold of absolute gravitational failure. The direct collapse hypothesis represents a mathematically valid physical pathway, but it requires a set of cosmological conditions that are statistically exceptionally rare. The cloud must be incredibly massive, it must remain uncontaminated by heavy elements, and it must be perfectly illuminated by a highly specific neighboring radiation source at exactly the right time. While this exotic mechanism might explain the existence of one or two isolated anomalies, it statistically cannot account for the sheer overwhelming abundance of massive singularities currently being detected across the deep infrared background. The direct collapse model is theoretically beautiful, but it is fundamentally too fragile and entirely too rare to serve as the definitive solution to the time crisis. I used to believe the violent gravitational collapse of massive dying stars was the most extreme physical process in the cosmos, but the theoretical reality hidden within the very first microsecond of creation is fundamentally more disturbing. When both standard stellar evolution and extreme accretion models fail to provide enough time to build these massive singularities, we are forced to look beyond the era of stars entirely. We must rewind the cosmic clock all the way back to the absolute beginning, to the highly chaotic quantum environment immediately following the initial expansion event. In the early 1970s, theoretical physicist Stephen Hawking proposed a radically different origin mechanism for singularities that entirely bypasses the need for stellar life cycles. This theoretical framework introduces the concept of primordial black holes. According to this hypothesis, in the unimaginably dense and hyper-energetic environment of the universe, just fractions of a second after the Big Bang, the fundamental distribution of matter and radiation was not perfectly uniform. The universe was a violently unstable state of extreme thermal and quantum fluctuations. In this specific environment, microscopic variations in energy density could be rapidly magnified. If a highly localized pocket of this primordial plasma became sufficiently dense, the outward thermal radiation pressure would instantly fail to counteract the overwhelming localized gravitational pull. That specific region of expanding space would immediately and violently collapse in on itself, crushing the raw primordial energy directly into a singularity long before a single stable atom of hydrogen had even formed. This represents a profound conceptual shift in astrophysics. Primordial black holes are not the terminal remnants of a dying cosmic era. They are the original structural seeds embedded directly into the foundational geometry of reality. They were essentially forged at the exact same moment that time itself began. If these primordial entities physically exist, they theoretically provide the perfect structural solution to the chronological paradox we are currently facing with the deep field data. Because they completely bypass the billions of years required for stellar evolution, they would already be physically present and actively functioning in the cosmic dark ages, waiting for the expanding universe to cool enough to begin accreting mass. The infrared sensors of the telescope would not be looking at an impossibly fast-growing object. They would simply be observing an ancient foundational mechanism that has been operating since the literal dawn of time. However, placing the origin of these massive structures at the exact moment of the Big Bang does not entirely solve the mystery. It merely shifts the mathematical crisis from the realm of classical astrophysics directly into the infinitely more complex and unpredictable domain of quantum mechanics. We must now calculate if the initial expansion event was mathematically capable of producing primordial seeds massive enough to realistically bridge the gap to the billion solar mass structures we are currently observing. If primordial black holes were truly forged at the dawn of time, we must confront an environment that actively defies classical physics, an era where microscopic probability dictated the macroscopic architecture of reality. To understand how a macroscopic singularity could spontaneously materialize without a stellar progenitor, we must examine the specific condition of the universe precisely 10 to the power of minus 35 seconds after the initial expansion event. At this exact chronological marker, the cosmos was not a smooth, continuous distribution of energy. It was operating strictly under the chaotic and fundamentally unpredictable rules of quantum mechanics. Theoretical physicist John Wheeler mathematically described the foundational fabric of space-time at this microscopic level as quantum foam. At the absolute smallest measurable boundary of existence, known in physics as the Planck-length empty space, is not truly empty. It is a violently turbulent boiling foundation of virtual particles constantly phasing into and out of physical reality. Energy and mass are locked in a relentless statistical fluctuation, creating extreme temporary spikes in local gravitational density. Under normal cosmological conditions, these microscopic density spikes immediately annihilate themselves and dissolve back into the quantum background without consequence. But the primordial universe underwent a violently destabilizing phase transition known as cosmic inflation. Driven by a repulsive vacuum energy, the actual physical fabric of space-time expanded exponentially, stretching at a velocity significantly exceeding the speed of light. This hyper-accelerated period of expansion acted as a universal magnifying glass. It took those microscopic temporary quantum fluctuations and instantly stretched them to massive macroscopic astrophysical scales before they had the opportunity to mathematically dissolve. The quantum probability was permanently physically frozen into the structural geometry of the expanding universe. In specific localized regions where the random quantum dice roll resulted in a remarkably high concentration of primordial energy, that density spike was suddenly amplified into a massive macroscopic gravitational well. The surrounding outward expansion of space was simply not powerful enough to overcome the localized crushing force of this newly amplified quantum anomaly. The geometry of space-time essentially collapsed in on itself, instantly crushing the hyperdense primordial plasma into a dimensionless singularity. This violent inflationary mechanism provides a mathematically robust pathway for the sudden creation of massive gravitational seeds long before the first fundamental atoms even possess the thermal stability to properly form. It suggests that the immense astronomical structures currently being detected by the James Webb Space Telescope are not the logical product of billions of years of gradual organized cosmic evolution. They are the direct physical manifestations of quantum turbulence violently stretched across the void by the sudden inflationary expansion of the early universe. When we analyze the infrared spectroscopic data of these anomalies, we're not looking at the end of a life cycle. We are looking directly at the amplified quantum noise of creation itself fundamentally preserved in the dark. While the extreme magnification of quantum foam provides a mathematically viable mechanism for creating primordial gravitational seeds, the fundamental laws of thermodynamics aggressively work to destroy them. I used to think that once a singularity was forged, it was a permanent, indestructible scar on the fabric of reality, but theoretical physics demands a much more complex and violent interaction. We must introduce the groundbreaking theoretical work of Stephen Hawking, specifically the concept of black hole evaporation. A singularity is not perfectly entirely black. In the microscopic quantum realm immediately surrounding the event horizon, the vacuum of space is constantly boiling with virtual particle and antiparticle pairs. Normally, these pairs instantly annihilate each other. However, if this quantum fluctuation occurs precisely on the boundary of the event horizon, the extreme gravitational gradient can physically separate the pair. One particle is dragged inescapably into the singularity while the other is propelled outward into the universe. To satisfy the absolute law of energy conservation, the particle that escapes must draw its thermal energy directly from the mass of the black hole itself. This continuous microscopic thermodynamic leak is known as Hawking radiation. Over vast periods of cosmic time, the singularity is quite literally slowly bleeding its mass away into the freezing void. Here is where the primordial black hole hypothesis encounters a catastrophic mathematical wall. The rate of Hawking radiation is inversely proportional to the mass of the singularity. A supermassive black hole bleeds energy so incredibly slowly that its lifespan practically extends into eternity. But the primordial seeds forged by quantum density spikes during cosmic inflation are fundamentally incredibly small. Because they possess such microscopic mass, their surface gravity is radically intense, resulting in a hyper-accelerated rate of thermal evaporation. The vast majority of these primordial seeds would not have survived the brutal dark ages of the early universe. Instead of aggressively consuming surrounding primordial gas and growing into massive structures, they would have violently evaporated, shrinking rapidly, before completely detonating in a blinding flash of high-energy gamma rays, long before the first stars even ignited. Even if we deliberately adjust our supercomputer models to assume the creation of the absolute largest possible primordial seeds, mathematically allowed by the inflationary period, they still emerge into the universe with a severe mass deficit. They might survive evaporation, but they are still fundamentally too small to bridge the staggering mathematical gap required to reach 1 billion solar masses within 500 million years. The quantum origin theory is mathematically beautiful and structurally elegant, but it ultimately leaves us staring at the exact same chronological paradox. The early universe simply did not provide the thermodynamic conditions necessary to sustain and grow these massive gravitational engines from scratch. If the standard quantum fluctuations of the early universe failed to provide seeds massive enough to survive the thermodynamic reality of evaporation, we are forced to re-examine the invisible scaffolding of the cosmos itself. We must address the most pervasive and elusive physical component of our universe, dark matter. For decades, astrophysics has operated under the assumption that dark matter is a fundamentally passive, unreactive substance, consisting of weakly interacting massive particles that slowly, gently clump together over billions of years to form the gravitational halos that eventually gave birth to galaxies. But the sudden mathematically impossible appearance of billion solar mass singularities in the extreme early universe suggests a much more violent and symbiotic relationship between dark matter and black hole formation. What if our standard particle model of dark matter is entirely incomplete? Some theoretical physicists are now proposing that the massive singularities currently being detected by the James Webb Space Telescope are not separate, isolated entities forming within a pre-existing dark matter halo. Instead, they are suggesting that these giant primordial black holes might actually be the visible manifestation of the dark matter structure itself. If dark matter in the extreme pressures of the early universe possessed a mechanism to shed its kinetic energy, perhaps through dark sector interactions or exotic self-interacting physics, it could theoretically undergo catastrophic gravitational collapse directly into supermassive singularities. Alternatively, we must consider the possibility that these massive ancient black holes are merely the visible tips of an unimaginable iceberg composed entirely of asteroid mass, primordial black holes, acting as the dark matter fundamentally swarming and merging in the dark. If these massive early black holes and dark matter are fundamentally born from the exact same primordial physics, it fundamentally shifts our understanding of galactic architecture. The black hole did not form inside the galaxy. The black hole formed first acting as an immense hyperconcentrated gravitational anchor, violently dragging the invisible dark matter web inward and ultimately forcing the early chaotic hydrogen gas to rapidly assemble around it. This flips the entire standard cosmological model upside down. The singularities are not the end product of a dark matter halo. They are the central engines that forced the halo to rapidly condense. However, while this dark matter connection provides a mathematically elegant structural solution, it still fundamentally requires an unknown exotic physics that we cannot yet test in our terrestrial particle accelerators. We are attempting to solve one profound astronomical mystery by invoking an even greater, invisible unknown. For nearly half a century, the lambda cold dark matter model stood as the undisputed architectural blueprint of reality, but today it is mathematically collapsing under its own weight. In the realm of theoretical astrophysics, this model is not merely a hypothesis, it is the foundational bedrock of our entire cosmological understanding. It dictates a universe governed by two elusive and invisible components. The lambda represents dark energy driving the accelerated expansion of space, while cold dark matter provides the necessary gravitational framework to slowly pull ordinary gas together. According to this highly protected standard model, cosmic structures must form strictly from the bottom up. Microscopic gas clouds slowly merge to form small dwarf galaxies, which then spend billions of years violently colliding and combining to eventually construct massive entities like our Milky Way. It is a slow, methodical and mathematically predictable process of cosmic assembly, but the raw infrared data downloading from the James Webb Space Telescope directly contradicts this slow bottom-up assembly timeline. We are not finding fragmented baby galaxies struggling to assemble in the dark. We are finding fully matured galactic empires anchored by billion solar mass black holes, existing precisely where the standard model dictates there should only be primitive gas and dust. The reaction within the global astronomical community has shifted from initial awe to a state of profound theoretical panic. We are currently witnessing an unprecedented flood of academic papers being rushed to publication as astrophysicists desperately attempt to introduce complex mathematical patches to save the lambda cold dark matter framework. They are proposing exotic magnetic fields, hyper-accelerated star formation rates, and highly unusual dark matter behaviors simply to force the observational data to fit the established timeline. But these mathematical patches are becoming increasingly strained and statistically improbable. The raw spectroscopic data is entirely indifferent to our theoretical comfort. It is cold hard and mathematically undeniable. The universe is loudly demonstrating that the foundational equations we have used to map reality for the last 50 years are either fundamentally incomplete or entirely wrong. We are standing on the precipice of a massive paradigm shift in human knowledge. When the undisputed standard model of the cosmos can no longer explain the physical structures we are actively observing through our telescopes, science is forced to abandon the safety of established theory and venture into the terrifying realm of the unknown. If the foundational equations of the lambda cold dark matter model are mathematically incapable of assembling these massive structures, within the permitted chronological window, we are forced to fundamentally invert our understanding of cosmic cause and effect. For half a century, the established astrophysical consensus maintained that galaxies were the primary structural units of the universe. In this traditional framework, a supermassive black hole is merely a secondary byproduct, a parasitic entity that slowly forms and feeds at the absolute center of a pre-existing galactic gravity well. The conventional wisdom rigidly dictated that the galaxy must create the black hole, but the deep infrared spectroscopic data retrieved by the James Webb Space Telescope strongly suggests the exact inverse is physically true. We are observing billion solar mass singularities operating in extreme primordial environments where the surrounding galactic infrastructure is profoundly underdeveloped or entirely mathematically absent. This stark observational reality leads to a radical and mathematically elegant conclusion. The black hole did not form inside the galaxy. The black hole formed first. We must abandon the classical view of these massive singularities as the terminal destroyers of cosmic structure and begin recognizing them as the primary gravitational engineers of the early universe. In the highly chaotic, hyperheated environment of the primordial void, ordinary hydrogen and helium gas is simply too violently energetic to naturally condense into stars. It requires an overwhelming continuous external physical force to overcome its own internal thermal outward pressure. A pre-existing supermassive singularity provides exactly that mechanical advantage. By establishing an immediate and unimaginably deep gravitational well in the early universe, these primordial entities acted as massive architectural anchors. Their extreme localized gravity actively dragged in vast oceans of primordial gas from the expanding void, violently compressing it and physically forcing the thermodynamic conditions necessary for the gas to cool, fragment, and ignite into stars at a radically accelerated rate. Furthermore, the intense radiation generated by the massive accretion disks of these singularities would have actively ionized the surrounding interstellar medium, violently pushing complex elements outward and chemically enriching the entire cosmic neighborhood. They were not just consuming matter, they were actively sculpting the physical conditions required for rapid galactic assembly. This concept of active gravitational engineering fundamentally solves the galactic assembly paradox. The galaxies of the cosmic dawn did not require several billion years to slowly pull themselves together through random, inefficient structural mergers because they were being aggressively and systematically built around pre-existing massive central anchors. The supermassive black hole was the necessary physical catalyst that forced the chaotic early universe to organize itself. But while this inverted architectural model perfectly explains how the first galaxies managed to form so rapidly, it violently returns us to the absolute core of the chronological crisis. If these massive gravitational anchors had to physically exist first in order to engineer the early galaxies, how did the anchors themselves come into existence when time itself had just begun? When the mathematical limitations of building supermassive singularities within a 500 million year window become entirely physically impossible, a highly controversial faction of the astrophysical community inevitably attempts to modify the foundational timeline itself. If the structural models cannot physically accelerate the growth of the black hole, then the only remaining mathematical variable is the absolute age of the universe. For decades, the cosmic microwave background has rigidly anchored the Big Bang at exactly 13.8 billion years ago. But the profound chronological crisis triggered by the James Webb Space Telescope deep field data has resurrected a deeply debated and historically discarded theoretical framework known as the tired light hypothesis. This alternative cosmological model proposes a fundamental reinterpretation of the redshift data we collect from the distant universe. In the standard model, the light from ancient galaxies is stretched into the infrared spectrum because the physical fabric of space itself is rapidly expanding. The tired light hypothesis fundamentally argues against this mechanical expansion. It proposes instead that photons travelling across vast cosmological distances slowly lose their intrinsic kinetic energy simply through constant continuous interactions with the microscopic quantum vacuum or the interstellar medium. As the photon progressively loses energy over billions of light years, its wavelength naturally stretches toward the red end of the spectrum, simulating the exact mathematical appearance of spatial expansion. Recently, some theoretical physicists have attempted to forcefully fuse this tired light concept with the idea of evolving coupling constants, suggesting that the fundamental forces of nature actively shift their strength over immense cosmological epochs. When this highly exotic hybrid framework is applied to the raw spectroscopic data returning from the Webb telescope, the mathematics produce a staggering chronological result. The newly proposed equations forcibly stretch the absolute age of the universe from 13.8 billion years to an unprecedented 26.7 billion years. This radical proposition essentially doubles the chronological history of human existence overnight. From a purely structural astrophysical standpoint, this massive temporal extension perfectly solves the massive accretion paradox. If the universe is actually 26 billion years old, the billion solar mass black holes we're currently observing in the deep field are no longer terrifying chronological anomalies. They suddenly possess an abundant temporal window of several billion years to comfortably accrete their surrounding gas through standard classical physical processes before their emitted light even begins its long journey to our infrared sensors. However, the broader scientific consensus vehemently rejects this elegant chronological shortcut. Doubling the absolute age of the universe inherently breaks almost every other meticulously established physical measurement in modern astrophysics. It directly contradicts the highly precise thermal mapping of the cosmic microwave background collected by the Planck satellite, and it strictly requires an entirely unproven exotic physical mechanism for photon degradation that we have never observed in a terrestrial laboratory. The scientific community cannot simply rewrite the fundamental history of time and discard decades of independent, rigorously tested observational data just to neatly explain the existence of one specific set of massive gravitational engines. The physical timeline of the cosmos remains rigidly mathematically locked at 13.8 billion years, violently forcing us to abandon standard linear chronology and look for a significantly more profound structural explanation. When modifying the fundamental age of our universe systematically breaks the established laws of thermodynamics, we're left with only one mathematically viable exit strategy. We must completely abandon the concept of a singular absolute beginning. If a supermassive singularity rigidly requires 20 billion years of continuous physical accretion to reach its observed mass, but the cosmic microwave background definitively proves our expanding space-time is only 13.8 billion years old, the mathematical deduction is as cold as it is terrifying. The physical assembly of these massive gravitational engines did not occur within our current chronological epoch. To resolve this catastrophic paradox, we must introduce the groundbreaking theoretical framework championed by Nobel laureate Sir Roger Penrose. For decades, the absolute consensus in theoretical astrophysics was that the Big Bang represented the literal creation of space-time itself. In this classical model, asking what existed before the initial expansion event is a mathematically meaningless question, essentially equivalent to asking what lies north of the North Pole. The singularity of the Big Bang was considered an absolute impenetrable physical boundary. However, Penrose rigorously analysed the extreme mathematics of black hole thermodynamics and general relativity, and concluded that this absolute boundary might be a mathematical illusion. When the scientific community exhausted every conventional physical mechanism to construct a billion solar mass black hole within a 500 million year window, Penrose provided a radical but mathematically rigorous alternative. He proposed that the Big Bang was not a definitive beginning, but rather a violent transitional boundary between two distinct cosmic epochs. If the mathematics dictate that these immense gravitational structures possess a physical age that predates our own expanding reality, then the only logical conclusion is that they were inherited. We are not observing newly formed structures struggling to assemble in the Dark Ages. We are looking directly at ancient supermassive entities that fundamentally survived the catastrophic death of a previous universe physically passing through the extreme quantum bottleneck of the Big Bang to become the primary architectural anchors of our own early cosmos. This is not science fiction. It is a desperate mathematical necessity forced upon us by the undeniable spectroscopic data currently sitting on our supercomputers. The limits of our physical reality have been violently breached, forcing us to seriously model a cosmological framework where our specific universe is merely one localized iteration in an infinite and eternal sequence of cosmic cycles. If we are to seriously consider the mathematical possibility that we are living among the gravitational ruins of a previous universe, we must first understand exactly how a cosmological cycle physically ends. To grasp the mechanics of Sir Roger Penrose and his conformal cyclic cosmology, we have to project our current physical models trillions of years into the deep future, long after the last star has permanently exhausted its nuclear fuel. In the standard thermodynamic trajectory of our expanding cosmos, the universe does not end in a sudden violent catastrophe. It ends in a slow, inescapable process of total thermodynamic equilibrium formerly known as the heat death. As the metric expansion of space continues to accelerate, driven by the relentless repulsive force of dark energy, the distances between galactic clusters will become so vast that gravity can no longer bind them together. The interstellar gas clouds required to forge new stars will eventually be entirely consumed or dispersed into the freezing void. One by one, the remaining luminous bodies will quietly extinguish, leaving behind an absolute darkness, dominated entirely by dead stellar remnants, white dwarfs, neutron stars, and supermassive black holes. Over unimaginably vast epochs extending into googles of years, even the dead stellar remnants will decay or be violently consumed by the central galactic singularities. Eventually, the only macroscopic physical structures remaining in the entire cosmos will be the supermassive black holes themselves holding court over an empty, infinitely expanding darkness. But as we established earlier in the thermodynamic principles of Hawking radiation, a singularity is not eternal. Over timescales that simply defy human comprehension, these final massive engines will slowly bleed their mass away into the vacuum. They will violently evaporate, returning their locked energy back into the universe as a highly diffuse mist of elementary particles and low-energy photons. When the final supermassive black hole finally detonates in a burst of gamma radiation, the physical universe will have reached its absolute maximum state of entropy. There will be no massive structures left to manipulate gravity. There will be no thermal gradients left to perform physical work. The cosmos will be a perfectly uniform, infinitely cold ocean of massless photons relentlessly stretching across an endless void. In classical physics, this state represents the absolute finality of existence. It is the permanent end of time and structure. But in the highly advanced mathematical framework of Penrose, this exact state of infinite empty thermal equilibrium is not a conclusion. It is the precise mechanical trigger for a new beginning. To comprehend how the absolute physical death of our universe can directly trigger the birth of the next, we must explore the highly abstract mathematics of conformal geometry. When Sir Roger Penrose analysed the ultimate heat death of the cosmos, he realised a profound physical truth about a universe populated entirely by massless radiation. In standard relativity, the fundamental concepts of time and space are strictly anchored to the existence of physical mass. Mass creates gravity. Gravity bends space. And moving mass provides the physical metric by which we measure the passage of time. But when the final supermassive black hole completely evaporates, returning its locked energy to the void, the universe is left entirely devoid of any physical mass. It becomes a boundless ocean of massless photons. According to the absolute laws of relativity, a photon traveling at the speed of light experiences zero passage of time and zero spatial distance. To a photon, the entire infinite expanse of the dying universe is simultaneously everywhere and nowhere. Without mass, there are no physical clocks left to tick. Without mass, there are no physical yardsticks left to measure distance. In this extreme thermodynamic state, the fundamental geometry of space-time completely loses its physical scale. The universe forgets how large it is. This is where Penrose applies the concept of conformal symmetry. In conformal mathematics, two geometric spaces are considered identical if their internal angles remain the same regardless of their absolute physical size. Penrose mathematically demonstrated that an infinitely cold, infinitely expanded universe devoid of mass is conformally identical to an infinitely hot, infinitely dense singularity. When the universe reaches absolute maximum entropy, and the metric scale of space-time completely dissolves the mathematical boundary between the infinite void and the microscopic quantum point, effectively vanishes. The end state of our dying reality perfectly mathematically maps onto the exact physical conditions required for a sudden expansion event. In this cyclical cosmological framework, the universe does not reset or bounce back in a classical mechanical sense. The infinite cold expanse simply becomes the infinitely dense singularity of the next cosmic iteration. Penrose terms each individual universe in this endless chain an aeon. The Big Bang was not the beginning of time, it was simply the conformal boundary where the previous aeon ended and our current aeon began. This mathematical transition provides the exact theoretical mechanism required to transport physical information and gravitational architecture across the boundaries of time, allowing the massive structures we observe today to fundamentally exist long before our own specific universe officially began. If the transition between two distinct cosmic eons mathematically preserves conformal symmetry, it fundamentally dictates that specific thermal information can survive the extreme violence of the Big Bang. The supermassive black holes of the previous universe did not cross the conformal boundary as solid physical mass. They crossed as highly concentrated localized spheres of electromagnetic energy, generated by trillions of years of continuous Hawking evaporation, when the infinite dying void of the previous eon effectively became the hyper-dense singularity of our current universe. That specific concentrated radiation did not seamlessly blend into the new primordial plasma. It physically punched through the expansion event, leaving a permanent thermodynamic scar on the foundational architecture of our newly forming space-time. In the rigorous mathematical framework of conformal cyclic cosmology, Sir Roger Penrose explicitly predicted the existence of these distinct thermal anomalies and formally classified them as Hawking points. Penrose and his mathematical colleagues have spent years meticulously analysing the polarised temperature fluctuations within the cosmic microwave background data collected by the Planck satellite. They have mathematically isolated specific circular regions where the localised thermal variance radically defies standard inflationary models. These anomalous rings of temperature represent the exact physical coordinates where the intense concentrated energy of a dead supermassive black hole from the previous aeon violently injected itself into our early universe. Now we must forcefully connect this profound theoretical architecture directly back to the catastrophic empirical data currently paralysing the astronomical community. The James Webb Space Telescope is observing billion solar mass singularities operating a mere 500 million years after the initial expansion event. The standard lambda cold dark matter model fundamentally fails to explain this, because it mathematically assumes the universe started as a perfectly blank slate. But if we apply the physical mechanics of inherited Hawking points, the chronological paradox instantly dissolves. A region of the early cosmos dominated by a massive Hawking point possesses an overwhelming foundational energy advantage. It does not require billions of years to slowly grow a supermassive singularity from a tiny stellar seed, because the immense localized gravitational and thermodynamic conditions required to force massive primordial hydrogen clouds into immediate direct collapse were already structurally embedded into the local space-time. The impossible primordial quasars we are desperately trying to mathematically explain are not chronological errors. They are the direct physical manifestations of inherited energy actively blooming in the precise locations where the greatest supermassive engines of the previous universe violently died. We are fundamentally observing the resurrected architecture of a dead reality. When we finally accept that the profound chronological anomalies captured by the James Webb Space Telescope are not mathematical errors, but the inherited gravitational architecture of a previous aeon, our entire perspective on existence permanently shifts. We are no longer looking at a universe that slowly constructed itself from absolute nothingness. We are residing within a cosmic ecosystem that is fundamentally built upon the colossal graves of its predecessors. The supermassive black holes we observe at the dawn of our time are not our native creations. They are the surviving ghosts of a forgotten eternity violently punched through the inflationary boundary to anchor the galaxies we inhabit today. The cosmos is not a single linear story with a definitive beginning and a freezing end. It is an infinite unbroken chain of catastrophic deaths and magnificent rebirths. The light entering our telescopes today carries the thermodynamic scars of structures that conquered the void trillions of years before our own time began. We are merely the current inhabitants of an eternal cycle living out our brief biological moments in the gravitational shadow of dead universes. But while these ancient singularities provide a terrifying solution to the mysteries of the cosmic dawn, there is a far more immediate and dangerous gravitational anomaly actively operating in our own local cosmic neighborhood right now. Next week we are leaving the primordial dawn to investigate a massive unseen structure located just beyond the zone of avoidance, a structure so overwhelmingly powerful that it is actively dragging the entire Milky Way and thousands of neighboring galaxies towards an unknown violent destiny at millions of miles per hour. The theoretical implications of what waits for us in the dark are fundamentally terrifying. You absolutely do not want to miss this revelation, so secure your connection to this channel immediately. The universe is actively hiding its most dangerous secrets in the blind spots of our own galaxy, and we are about to pull back the veil. I used to look up at the night sky and find profound comfort in the absolute stillness of the stars, but that cosmic silence is the greatest physical lie ever told to human perception. We are fundamentally conditioned by our terrestrial biology to believe that the ground beneath our feet is a fixed, permanent anchor in reality. Even when our primitive ancestors finally understood that the Earth is not the center of the cosmos, our intuition simply scaled up the illusion to accommodate a larger neighborhood. We accept that our planet is hurtling through the vacuum of space at approximately 107,000 kilometers per hour, perpetually chained to the invisible gravitational well of our host star. We understand that our entire solar system is locked in a sprawling, violent galactic orbit, moving at over 800,000 kilometers per hour around the supermassive singularity positioned at the exact center of the Milky Way. These astronomical velocities are mathematically staggering to the human mind, yet they still provide a psychological sense of organized cosmic stability. They represent closed, predictable thermodynamic loops. They are a comforting mechanical clockwork operating endlessly in the dark. But the brutal reality of advanced astrophysics dictates that there is absolutely no state of rest anywhere in the structural architecture of the universe. When modern cosmologists began to meticulously map the thermal radiation left over from the very birth of reality, known as the cosmic microwave background, they discovered a terrifying directional anomaly hidden within the raw data. One specific hemisphere of the observable sky is definitively fundamentally hotter than the other. This phenomenon, known in theoretical physics as the dipole anisotropy, acts as the ultimate universal speedometer. It completely shattered the illusion of our galactic stability. The mathematical interpretation of this thermal shift definitively proves that the entire Milky Way galaxy, containing hundreds of billions of stars and trillions of planets, is not simply drifting aimlessly through the expanding void. We are currently in a state of catastrophic gravitational freefall. Our entire galactic neighborhood is actively plunging through the freezing intergalactic medium at the staggering velocity of approximately 2.2 million kilometers per hour. We are effectively strapped to the surface of a cosmological bullet screaming blindly into the dark. And the most terrifying aspect of this immense structural movement is not the sheer unimaginable speed itself. It is the absolute mathematical certainty that gravity does not simply pull without a massive physical source. An acceleration of this specific magnitude strictly requires an accumulation of mass so unimaginably vast that its localized gravitational influence fundamentally warps the structural geometry of our entire local universe. We are not just moving. We are being violently dragged across millions of light-years of empty space toward a highly specific, unknown destination. There are absolutely no brakes on this cosmic trajectory, and there is no physical mechanism known to theoretical astrophysics that can possibly halt our continuous descent. We are helplessly falling together with our galactic neighbours toward an invisible architectural behemoth, pulling us inexorably into the deepest, blackest abyss of the night sky. We are racing toward a collision course with a ghost. When astrophysicists first calculated the terrifying velocity of our localized galactic trajectory, they immediately turned their optical observatories toward the calculated destination to identify the source of this overwhelming gravitational pull. They mathematically traced the acceleration vectors backwards and plotted the exact coordinates in the sky where this unseen behemoth had to reside. But when they aligned their lenses and captured the light from that specific region, they were met with an absolute blinding darkness. They did not find a supermassive galaxy cluster or a hyperactive quasar. They found a wall. To understand the sheer frustration of this astrophysical paradox, you must visualize the physical architecture of our own Milky Way galaxy. We do not live in a spherical cloud of stars. We inhabit a highly flattened rotating spiral disk spanning over 100,000 light-years across, because our solar system is physically embedded deep within the outer suburbs of this spiral disk. Whenever we attempt to look outward along the equatorial plane of our galaxy, our line of sight is immediately blocked. We are forced to look through tens of thousands of light-years of violently swirling interstellar gas, dense molecular clouds, unignited stellar nurseries, and the accumulated radiant glare of billions of foreground stars. This thick galactic equator acts as a fundamentally impenetrable optical barrier. It physically absorbs and scatters visible light, preventing any photons from the distant universe beyond from ever reaching our terrestrial sensors. In the meticulous maps of the early cosmological surveys, this immense blind spot was formally designated as the zone of avoidance. It covers approximately 20% of the entire observable sky. For decades, humanity was able to map the vast, majestic superclusters expanding in the northern celestial hemisphere and catalogue the sprawling cosmic web in the southern hemisphere. But this massive central band remained a terrifying black void on our cosmological maps. It is the ultimate cosmic irony. We have successfully captured the faint afterglow of the Big Bang itself from over 13 billion light-years away, yet we are completely blinded by the dust on our own front porch. And the chilling reality of the cosmic microwave background dipole data is that the exact center of our catastrophic gravitational freefall points precisely into the thickest, most impenetrable region of the zone of avoidance. The architectural behemoth that is actively dragging the Milky Way and all of our galactic neighbors to an unknown doom is deliberately hiding in the one specific place in the entire sky where our optical telescopes are fundamentally mathematically blind. We are being pulled into the dark by a predator that has perfectly positioned itself behind the blinding glare of our own galactic core. For generations of astronomers, this optical barrier created an excruciating psychological barrier. Imagine being locked inside a moving vehicle entirely aware that it is accelerating wildly out of control, but the windshield is completely painted over. You can feel the mechanical force pressing you into your seat. You can mathematically calculate your current velocity and trajectory with absolute precision, but you are fundamentally denied the ability to see the brick wall rapidly approaching in the darkness ahead. The scientific community was effectively paralyzed by this paradox. They knew the mass required to generate such an immense gravitational localized pull had to be equivalent to tens of thousands of Milky Way galaxies combined. A structure of that incomprehensible magnitude could not simply be a collection of dark matter. It had to contain billions of luminous stars radiating unimaginable amounts of energy. Yet the zone of avoidance swallowed this light completely. The dust particles within our galactic disk are perfectly sized to interact with and absorb the wavelengths of standard visible light, efficiently converting the energy of those distant stellar photons into microscopic local heat before they ever breach the boundary of our solar system. The universe had essentially placed a massive physical sensor bar over the most critical structural anomaly in our localized reality. We were trapped in a state of terrifying ignorance, knowing the physics of our impending doom, but completely blind to its physical form. This was the era of the Great Astronomical Blockade. When faced with an impenetrable physical barrier, the human instinct is usually to build a larger lens, but to pierce the blinding dust of the Milky Way astrophysics demanded that we fundamentally change the frequency of our perception. For nearly a century, optical telescopes were the only tools we had to measure the cosmos, but visible light is remarkably fragile. The delicate wavelengths of optical photons are easily absorbed and scattered by the microscopic silicate and carbon dust particles suspended in our galactic disk. To see what was actively pulling us into the dark, we had to completely abandon human vision and rely on the invisible spectrum of electromagnetic radiation. The technological siege against the zone of avoidance began in earnest with the deployment of infrared satellites and massive radio dishes. While optical light is trapped by interstellar dust, infrared radiation possesses longer wavelengths, allowing it to slip through the dense molecular clouds like a ghost passing through a solid wall. Simultaneously, ground-based radio telescopes began scanning the exact same void, listening for the highly specific 21-centimeter emission line of neutral hydrogen gas. This signature radio wave passes through the galactic equator completely unhindered, bringing us the raw structural blueprints of the hidden universe. Later, the introduction of orbiting X-ray observatories added the final crucial layer of detection. X-rays do not show us the stars, they reveal the immense reservoirs of superheated gas that strictly exist in the terrifying gravitational crushing zones between massive galaxy clusters. By meticulously combining these three distinct invisible frequencies, infrared, radio, and X-ray astronomers slowly began to lift the heavy veil of our own galaxy. The process was agonizingly slow, requiring decades of continuous observation and complex mathematical filtering to separate the foreground noise of our own local stars from the faint ancient signals arriving from the deep background. But as the supercomputers compiled the data, the massive, terrifying black spot on our cosmological maps finally began to fill with light. What they found hidden in the optical dark was not a barren void. As the blurry outlines of the background universe snapped into focus, the astronomical community was met with a chilling realization. They were not looking at a few scattered anomalies. They had accidentally uncovered a massive, sprawling architecture of cosmic structures that defied all previous models of local galactic distribution. The blank wall was entirely populated, and as the individual data points merged into a coherent map, they revealed that this newly discovered territory was not static. The invisible spectrum had exposed the very gravitational machinery that was dragging us to our doom, and the scale of the structure waiting on the other side of the veil was fundamentally beyond human comprehension. When the veil of cosmic dust was finally lifted, we expected to find a single solitary culprit, but the reality was a violent mass migration of entire galaxies. As the radio and infrared surveys pierced the zone of avoidance, they did not just reveal a destination, they revealed a sprawling active current. To understand the sheer scale of this movement, we must first define our immediate neighbourhood. The Milky Way is not a solitary island. We are gravitationally bound to a localized cluster of approximately 80 individual stellar cities, formally classified as the local group. This includes our massive twin, the Andromeda Galaxy, the Triangulum Galaxy, and dozens of smaller dwarf satellites. For decades, classical cosmology operated under the assumption that while the universe as a whole was expanding uniformly outward, driven by the initial momentum of the Big Bang, our local gravitational bindings would keep this small neighbourhood relatively stable. This general outward expansion is known as the Hubble flow, and it dictates that practically everything in the cosmos should be moving away from everything else. But the data returning from the deep infrared surveys fundamentally broke this assumption. When astrophysicists mapped the trajectories of the galaxies within our local group and compared them against the expected baseline of universal expansion, they discovered a massive, terrifying discrepancy. This discrepancy is known as peculiar velocity. Our entire local group is completely ignoring the standard outward expansion of the cosmos. We are moving against the cosmic tide. We are actively being dragged sideways through the expanding vacuum as a unified cohesive unit, and we are not alone in this anomalous migration. As the observational net was cast wider to encompass neighbouring groups like the M81 and Centaurus associations, a horrifying pattern emerged. Hundreds of thousands of galaxies spanning tens of millions of light years are all exhibiting the exact same peculiar velocity. They are not drifting randomly. They are flowing together in highly organized parallel streams. The invisible gravitational architecture of the universe was suddenly exposed not as a static web, but as a dynamic, violently active watershed. We are essentially trapped in a cosmic river, a massive invisible current of dark matter and galactic superstructures, all plunging toward the exact same gravitational basin. The sheer mass required to pull a single galaxy against the expansion of the universe is mathematically staggering. The mass required to pull hundreds of thousands of galaxies simultaneously across millions of light-years of space completely shatters standard cosmological models. The entity waiting for us at the end of this river is not just a heavy object, it is a fundamental distortion in the fabric of reality itself. For a brief period in the history of modern cosmology, the astronomical community collectively exhaled a sigh of relief, believing they had finally located the ultimate destination of our localized cosmic river. But the strict mathematics of gravity ruthlessly shattered that temporary comfort. As we mapped the trajectory of our local group moving against the standard expansion of the universe, the initial data strongly pointed toward a massive neighbouring structural aggregation known as the Virgo cluster. To comprehend the scale of Virgo, you must understand that our entire local group with its dozens of galaxies is essentially just a microscopic rural suburb located on the extreme outer fringes of a sprawling metropolitan empire. The Virgo cluster is a terrifyingly dense concentration of over 2,000 individual galaxies, violently swirling around a common gravitational centre, anchored by an unimaginably massive elliptical galaxy known as Messier 87. This massive cluster contains trillions of stars and is structurally bound together by an invisible scaffolding of dark matter, so dense that it physically warps the optical light passing through it. It seemed entirely logical that this immense local behemoth was the primary source of our peculiar velocity. The initial working assumption was that the deep gravitational well of the Virgo cluster was simply dominating our local group, pulling us relentlessly toward its supermassive center to eventually merge with its swarming galactic population. The scientific world believed they had definitively found the final anchor of our local universe. But when theoretical physicists meticulously calculated the absolute total mass of the Virgo cluster, including all of its vast and invisible dark matter halos, and mathematically compared it directly to the staggering 2.2 million km/h velocity of our local group, the equations fundamentally violently failed to balance. The Virgo cluster is undeniably massive, but it is entirely mathematically insufficient to generate that specific level of localized acceleration across such vast cosmological distances. It simply does not possess the sheer gravitational muscle required to drag our entire neighborhood that incredibly fast. And then the deep field radio and X-ray surveys delivered the final catastrophic blow to the Virgo hypothesis. By isolating the specific spectral emission lines of the galaxies deep within the Virgo cluster itself, astronomers discovered that this massive metropolitan empire is not structurally stationary. The supposed ultimate gravitational anchor of our local universe is also physically falling. The entire Virgo cluster, encompassing thousands of galaxies and unimaginable reserves of primordial mass, is being dragged sideways through the expanding vacuum, exactly along the same terrifying trajectory as our own tiny local group. The realization was scientifically paralyzing. The massive cosmic entity we initially thought was actively pulling us turned out to be just another helpless victim caught in the exact same invisible current. Virgo was not the predator. It was simply a much larger piece of cosmic debris flowing down the exact same cosmological waterfall. The true architectural anomaly generating this incomprehensible gravitational pull was still hiding somewhere much deeper and much darker within the blinding dust of the zone of avoidance. When astronomers finally managed to mathematically bypass the immense gravitational interference of the Virgo cluster, they peered much deeper into the absolute center of the zone of avoidance and discovered an entity that completely shattered the standard model of local cosmology. The source of our terrifying 2.2 million km/h free fall was not a singular hyperactive quasar or a solitary supermassive black hole. It was a staggering concentrated aggregation of cosmic mass formerly designated as the Great Attractor, located approximately 250 million light-years away in the direct line of sight behind the Centaurus and Norma constellations. This localized gravitational anomaly represents an absolute architectural nightmare. To comprehend the sheer scale of the Great Attractor, we must fundamentally abandon the standard human concept of individual galaxies and begin thinking strictly in terms of oceanic cosmic currents and deep dark matter gravitation. When the advanced X-ray observatories finally pierced the dense dust of our galactic plane, they revealed a hyper-dense graveyard of ancient galaxy clusters actively cannibalizing each other in the dark. The beating heart of this gravitational beast appears to be the Norma cluster, a violently active and incredibly massive cosmic metropolitan center situated at the very bottom of this localized gravity well. But the Norma cluster is merely the visible luminous core of a much larger invisible framework. The Great Attractor is not a single solid physical object. It is essentially a localized gravitational basin, a massive concentrated depression in the fundamental fabric of space-time, where the invisible scaffolding of dark matter has woven itself into an incomprehensibly dense and heavy knot over billions of years. The mathematics required to calculate its total local mass are genuinely terrifying. It possesses a gravitational equivalent of tens of thousands of Milky Way galaxies combined into one dense specific region. This unimaginable concentration of dark matter and luminous mass generates a localized gravitational pull so overwhelmingly profound that it successfully overpowers the fundamental repulsive force of cosmic expansion across hundreds of millions of light-years of empty space. It is actively hauling our local group, the Virgo cluster, the Centaurus cluster, and the Hydra supercluster, along with hundreds of thousands of individual galaxies directly into its crushing center. We are effectively watching the slow, agonizing collapse of an entire corner of the universe. When this revelation was definitively confirmed, the global astrophysical community was forced to completely rewrite the established maps of the local cosmos. We were no longer living in a quiet, static neighborhood drifting peacefully through the void. We were confirmed to be residents of a violently active watershed, where every single piece of astronomical real estate within a radius of hundreds of millions of light years is actively draining into the Great Attractor. It was hailed as the ultimate cosmological boss, a central structural engine so incredibly immense that it forcefully dictated the physical trajectory of everything humanity had ever observed in our local sky. The terrifying mystery of our localized freefall appeared to be definitively solved. We had finally looked deep into the dark optical void of the zone of avoidance and found the exact monster pulling the strings. But the strict, unforgiving laws of theoretical physics are rarely satisfied with seemingly perfect conclusions. As astrophysicists continued to refine the mass calculations of the Norma cluster and the surrounding dark matter halo, they uncovered a devastating structural discrepancy that was about to plunge humanity into an even deeper level of existential dread. The Great Attractor was immensely powerful, but the math definitively proved it was still not heavy enough. The terrifying mathematical deficit of the Great Attractor forced astrophysicists to completely abandon their traditional methods of mapping the cosmos. If the Norma cluster and its surrounding dark matter halo did not possess the required mass to generate a 2.2 million km/h free fall, then our localized gravitational basin had to be physically connected to something unimaginably larger. For decades, astronomers defined cosmic structures purely by proximity grouping galaxies together, simply because they appeared close to each other in the sky. But in 2014, a team of researchers revolutionized our understanding of the universe by mapping the cosmos not by static physical location, but by the fluid dynamics of gravity itself. They meticulously tracked the specific directional velocities of over 8,000 galaxies, tracing their complex gravitational flow lines, like charting the microscopic currents within a massive raging river. What these velocity maps revealed was not a collection of isolated clusters, but a single continuous interconnected superstructure. They discovered that our Milky Way, the Virgo cluster, the Centaurus cluster, and the Great Attractor itself are all fundamentally bound together within an incomprehensibly vast gravitational watershed. This newly defined cosmic continent was formerly named Laniakea, a Hawaiian word translating to immeasurable heaven. To grasp the physical reality of Laniakea is to completely surrender any lingering sense of human significance. This singular astronomical structure spans over 520 million light-years across the darkness and contains the mass of 100 million billion suns distributed across approximately 100,000 distinct galaxies. When visualized through supercomputer simulations, Laniakea does not look like a sphere or a chaotic interstellar cloud. It possesses the delicate, sprawling geometry of an immense cosmic feather, or the intricate branching root system of a titanic tree. Within this staggering architectural framework, the Great Attractor is fundamentally demoted. It is no longer an isolated anomaly, but rather the central gravitational valley, the absolute lowest point in the Laniakea watershed, where all the intersecting cosmic streams and rivers of dark matter naturally flow and converge. And where does humanity exist within this immeasurable heaven? The Milky Way galaxy, along with our entire local group, is located at the absolute extreme outer edge of one of the longest, most fragile branches of this cosmic feather. We are a microscopic speck of dust caught on the outermost fringe of a massive gravitational hurricane, violently being pulled inward along the established flow lines toward the crushing center. Laniakea finally provided the complete structural map of our localized doom. It perfectly explained the physics of our trajectory and the mechanics of our inevitable descent. The dark mystery of the zone of avoidance appeared to be definitively resolved by the discovery of this majestic cosmic continent, but the relentless pursuit of absolute astronomical truth is often a deeply punishing endeavour. Just as the scientific community began to comprehend our microscopic place within the immeasurable heaven of Laniakea, the deepest, widest X-ray surveys pushed slightly past the theoretical boundaries of our newly discovered home, and detected a new gravitational signal. It was an anomaly so profoundly massive that it made the entire structural weight of Laniakea look like a mathematical rounding error. When the sprawling architecture of Laniakea was definitively mapped, the scientific community desperately wanted to believe it was the final boundary of our localized cosmic terror, but the brutal mathematics of gravity rarely allow for a peaceful conclusion. The massive structural weight of our newly discovered immeasurable heaven was still fundamentally insufficient to account for the total directional velocity of our local group. The Great Attractor, the terrifying gravitational anomaly we originally thought was the absolute center of our local universe, was exposed as merely a transitional way station. It is not the final boss, it is simply another immense cosmic tributary, flowing toward an even darker and heavier destination. By extending their X-ray surveys slightly beyond the theoretical borders of Laniakea, astrophysicists detected the true structural behemoth dominating our corner of the cosmos. Located roughly 650 million light-years away, directly behind the Great Attractor, sits the Shapley supercluster. If Laniakea is a sprawling cosmic continent, then Shapley is the gravitational tectonic plate upon which it rests. It is without question the most massive concentration of baryonic and dark matter within our observable local universe. This structure is so incomprehensibly massive that it possesses a localized gravitational pull strong enough to completely overpower the internal dynamics of Laniakea itself. The Shapley supercluster contains an estimated mass of 10,000 times that of our entire Milky Way galaxy, housing tens of thousands of massive galaxy clusters violently interacting within a hyperdense gravitational well. The realization of its existence fundamentally altered the hierarchy of cosmic power. We are not just falling toward the Great Attractor. The Great Attractor and the entirety of the Laniakea supercluster are actively being hauled bodily across the expanding void by the overwhelming gravitational dominance of Shapley. The localized free fall of our Milky Way is not a simple linear plunge, it is a terrifying multi-layered cascade. We are a microscopic satellite orbiting a star that is orbiting a galaxy that is falling toward the Virgo cluster, which is being dragged toward the Great Attractor, which is ultimately being consumed by the Shapley supercluster. It is a relentless, inescapable hierarchy of gravity, where every localized structure is inevitably subjugated by a heavier, more distant master. Yet even as the terrifying scale of the Shapley supercluster solidifies its position as the ultimate apex predator of our local reality, the raw cosmological data continues to hint at a deeper, more disturbing truth. The velocity vectors of our cosmic migration are still not perfectly aligned with the center of Shapley. There is a residual pull, a microscopic but undeniable mathematical drift, indicating that even this ultimate behemoth is being tugged by something else. We are being pulled toward a region of space that fundamentally exists beyond the absolute limits of human perception. When the Shapley supercluster was mathematically crowned as the ultimate apex predator of our localized reality, the astrophysical community assumed they had finally reached the absolute ceiling of cosmic architectural scale. The total mass of Shapley is so overwhelmingly immense that it comfortably accounts for the vast majority of our peculiar velocity, dragging Laniakea and the Great Attractor relentlessly into its gravity well. But when cosmologists began to analyze the deep thermal fluctuations in the cosmic microwave background with unprecedented precision, they discovered a residual mathematical drift that completely shattered the fundamental limits of the observable universe. Even after factoring in the titanic gravitational pull of the Shapley supercluster, entire sprawling networks of galaxy clusters are still moving significantly faster than standard cosmological models permit. They are being pulled by an additional unseen vector. This terrifying physical phenomenon is formally known in advanced astrophysics as the dark flow. To comprehend the sheer existential horror of the dark flow, we must first define the absolute physical boundaries of our reality. The observable universe is strictly limited by the speed of light and the absolute age of the cosmos. We can only see objects whose light has had enough time to reach our telescope since the initial expansion event 13.8 billion years ago. This creates a definitive spherical boundary around Earth known as the cosmological horizon. According to the strict laws of classical physics, whatever exists beyond this absolute horizon is mathematically disconnected from our reality. Because no physical information can travel faster than the speed of light. But gravity is not bound by the same temporal constraints as visible photons. The dark flow data definitively proves that hundreds of massive galaxy clusters, located deep within our observable universe, are being forcefully dragged in a highly specific direction toward a patch of sky situated between the constellations of Centaurus and Vela. They are moving at tremendous velocities toward a gravitational source that we cannot see. And the reason we cannot see it is not because it is obscured by local galactic dust like the Great Attractor. We cannot see it because it physically exists entirely outside the cosmological horizon. The dark flow is the ultimate architectural nightmare. It fundamentally proves that there are physical structures lurking in the unobservable universe. Structures so incomprehensibly massive that their gravitational influence aggressively bleeds across the boundary of light itself, physically hauling our visible reality toward an unknown destination in the infinite dark. We are not just falling toward the center of our local supercluster. Our entire observable universe is tilting and flowing toward an unseen, unfathomable mass that we will mathematically never be able to observe. The monsters hiding in the dark are no longer limited to our own galactic neighborhood. They exist in a realm of space that humanity is permanently forbidden from seeing, yet their gravitational reach is strong enough to dictate the ultimate physical trajectory of our entire cosmic existence. When we mathematically map the terrifying velocities of the dark flow and the overwhelming gravitational dominance of the Shapley supercluster, it is easy to assume that humanity is destined for a violent, crushing collision at the end of time, but the absolute truth of our cosmological fate is far more isolating. We are indeed falling into the dark at millions of kilometers per hour, continuously accelerating toward an unseen architectural behemoth, located beyond the absolute edge of the observable universe. But there is a secondary opposing force actively operating within the fundamental fabric of space-time, a force so powerful that it makes the combined gravitational pull of millions of galaxy clusters mathematically irrelevant. This relentless repulsive mechanism is known as dark energy. As we fall toward the Great Attractor and the Shapley supercluster, dark energy is simultaneously expanding the physical space between us and our destination at an exponentially accelerating rate. The horrific irony of our cosmic trajectory is that the universe is actively stretching faster than we are falling. We are essentially running on a cosmological treadmill that is constantly increasing its speed. The mathematics are absolute and unyielding. We will never reach the center of Laniakea. We will never collide with the Shapley supercluster. We will never uncover the entities pulling the strings of the dark flow. Trillions of years from now, the relentless expansion of dark energy will forcefully rip our local group away from the rest of the cosmic web. The distant galaxies will slowly fade from our night sky as the space between us expands faster than the speed of light, pushing them permanently beyond our cosmological horizon. Our descendants will look up into a completely empty black void, entirely unaware that the majestic superclusters and the terrifying gravitational rivers ever existed. We are not destined for a spectacular violent collision. We are destined to be violently severed from the rest of reality and trapped in an eternal freezing isolation. But while the slow, agonizing death of the expanding universe provides a melancholic end to our gravitational journey, the cosmos is currently hiding an active weapon of mass destruction that does not require trillions of years to execute. The universe is deceiving us with the slow mechanics of gravity, but it harbours a quantum anomaly capable of ending everything instantly. Next week, we're leaving the macrophysics of galaxy clusters to investigate a microscopic mathematical bubble of pure instability known as false vacuum decay. If this quantum death bubble makes contact with our reality, it will permanently erase the fundamental laws of physics and annihilate our entire universe at the exact speed of light. You will not see it coming, and there will be absolutely nothing left behind. Ensure your connection to this channel is secure. You absolutely do not want to miss the precise mechanics of the ultimate apocalypse.